the final lesson of Unit 3 for geometry, which is going to be classifying triangles and looking at their interior and exterior angles. So we are going to start with the fact that we have auxiliary lines now, and these lines are used to help us aid in or help us figure out how to solve a proof. And so these lines may or may not be drawn for you, but they help you find relationships and help you solve the proofs that you will be seeing here in the near future. So we are going to start with the triangle sum theorem. And this theorem just tells us that the sum of all of the angle measures inside of a triangle is 180 degrees. So if we were to look at this triangle, I could say angle A plus angle B plus angle C equals 180 degrees because I would need all three of those angles. So, after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the measure of angle XYZ. So, if we look, angle XYZ, we'd go from X to Y to Z. So, we are looking for this angle in here. And if you notice, we can draw a triangle if we connect these two lines right here. And in this triangle, we have 62 degrees and 40 degrees. So since it forms a triangle, we know we can subtract it from 180 so that we can figure out that third angle. So pull out the handy-dandy calculator if your mental math is not your strong suit. 180 minus 62 minus 40 would give you 78 degrees. So we know that the measure of angle XYZ would have to be 78 degrees. Okay, and then if you wanted to check, you could just put 78 in and add all those numbers up. So then, we want to use the diagram to find the measure of angle MJK. So if we look, MJK, we're going to go from M to J to K. So we want to know what this angle is. So looking at this, we do have a triangle formed if we were to connect it here. And we need to know what this angle is right here. If you notice, we have that arc mark, which tells us that this angle is congruent to this angle over here as well. And if you notice with this one, we have another triangle. Oopsie, come on, green. We have another triangle, and we know two of its angles, and we can find that angle there. So first, we're going to subtract from 180 with this 88 and 48, so we can figure out what that missing angle is for that smaller triangle. So 180 minus 88 minus 48 gives us 44 degrees. So if I know this angle is 44, I know this angle in here is also 44. And then I have the original triangle I was looking at, so I'm going to have 180 minus 104 minus the 44. And so 180, that would give us 32 degrees. So then we know that the measure of angle MJK is 32 degrees. So just make sure that when you're doing these problems, you are finding the correct angle and just taking your time and verifying you're talking about the right angle. So our next theorem is called the third angles theorem. And it says that if two angles of one triangle are congruent to two triangles of another triangle, or two angles of another triangle, the third pair of angles are congruent. So if you look at these, we have angle L is congruent to angle R, and angle M is congruent to angle S. So with that, we can automatically say that angle N is congruent to angle T. Ooh. There it is. 1, 2. Okay. So we want to find the measure of angle P and the measure of angle R. If you notice, we have two sets of congruent angles with these two triangles, so we can just set these two equations equal to each other. So we would have 2x squared, oopsie, equals 4x squared minus 32. So to begin with, we would want to get our x squareds together most likely. So we'll just subtract this minus, actually, you know what, we'll bring the 2x squared over because then we can factor. So that would give us 0 equals 4x squared minus 2x squared is 2x squared minus 32. And so with this, I'm going to add the 32, which would give me 32 equals 2x squared. And then I can divide by 2. And that gives me 16 equals x squared. And then to cancel out that x squared, we're going to take the square root, which gives us x equals 4. So then if we know that x equals 4, we can just plug it back into one of the originals. 2 times 4 squared, that would give us 2 times 16, which is 32 degrees. Yay! So now if we want to find angle C and F, again, a similar situation, 2 pairs of congruent angles, so we know that these two that we have are also congruent, so we can set them equal to each other. 4x squared equals 3x squared plus 125, or plus 25, I'm blind. There you go. So I would want to get the x squareds together because when we don't have a term that just has x, then we can usually just solve by taking the square root of some numbers. So we're going to subtract 3x squared minus 3x squared. That gives us x squared equals 25. So then to cancel out, we take the square root of both sides, and x equals 5. So then if x equals 5, we plug that back in so we can get the actual degree measure. 4 times 5 squared, or 4 times x squared. That would give us 4 times 25. Make sure you are not squaring both the 4 and the 5, or multiplying 4 times 5 and then squaring. You do square just the 5 first. And then 4 times 25 is 100. So that would give us 100 degrees for these angles. So a corollary is a theorem whose proof follows directly from another theorem. Here are 2 corollaries to the triangle sum theorem. We have the acute angles of a right triangle are going to be complementary because if we have a right triangle, we know that the other 2 angles have to also add up to 90 degrees. Oops. And so if you notice, angle D and E would be complementary when you add them up. And then the measure of each angle of an equal angular triangle is 60 degrees. And that is because when you have 180 degrees evenly split between 3 angles, that gives you 60 degrees per angle. The measure of one acute angle in a right triangle is 63.7 degrees. What is the measure of the other acute angle? If we were doing this, we know we have a right triangle, so automatically we can do 180 minus 90, which gives us 90 degrees. And then the other angle that we know is this 63.7 degrees. So when we subtract 63.7 from 90, that would give us 26.3 degrees for the other acute angle in that right triangle. Okay, so just in case you were unaware, the interior is the set of all points inside of a figure. So if we have this triangle, inside of the triangle is the interior, and then the exterior is everywhere outside of that triangle. Okay, so an interior angle is formed by 2 sides of a triangle. The ink's coming with. Goodness. So the interior is formed by two sides of a triangle, and the exterior is formed, ooh, goodness, these colors don't want to change. Formed by two sides of a triangle. An exterior angle is formed by one side of the triangle and an extension of an adjacent side. So if you look at the triangle we had above, angle 3 is an interior angle because it is inside, and angle 4 is exterior because it's surrounded by the blue. So each exterior angle has two remote interior angles, and the remote interior angles are the ones that are the farthest away from it. So they are also just not the ones touching it. If angle 4 is an exterior angle, the remote interior angles of angle 4 are angles 1 and 2. Notice they are the ones that do not touch the angle at all. All right, so then the exterior angle theorem tells us that the measure of an exterior angle of the triangle is equal to the sum of the measures of its remote interior angles. So that tells us that the measure of angle 4 is going to be equal to the sum of angle 1 and angle 2. Okay? So if we want to find the measure of angle B, we have the measure of angle A plus the measure of angle B equals the measure of angle BCD, which is this angle in here. So when we set that up, we would have 15 plus 2x plus 3 equals 5x minus 60. So when we combine our like terms, 15 plus 3 gives us 18 equals 5x minus 60. Oh, goodness. Then I would personally subtract the 2x so I could keep my x positive, and that would give us 18 equals 3x minus 60. Then add your 60 so that you can get it away from the x, and that would give you 78 equals 3x. And when you divide 78 by 3, that gives you x equals 26. So then if we know what that x equals 26 and we need to find the measure of angle B, we're going to plug it in. 2 times x, which was 26, plus 3. 2 times 26 is 52, plus 3 gives us 55 degrees for the measure of angle B. Okay. So now I want to find the measure of angle ACD. So since my exterior angle is right here, that means my remote interior angles are my 90 degree and this angle over here. So I know that these two added together will equal my exterior angle. So I'm going to have 6z minus 90 equals 90 plus 2z plus 1. When we combine like terms on the right, that's going to leave us with 2z plus 91. Oops, 91. There we go. And then I would like to combine my z's and keep them positive, so I would subtract the 2z personally. Oops. So that would give us 4z minus 9 equals 91. And then you would add the 9 to both sides, which gives us 4z equals 100. And then when you divide by 4, z equals 25. So then if I want the measure of angle ACD, we're going from A to C to D. That is this 6z minus 90. We are going to plug in 6 times z, which we found was 25, minus 9. 6 times 25 is 150, and minus 9 would give us 141 degrees for the measure of angle AC. Alrighty. So then the measure of angle H and the measure of angle J, again, this exterior angle is going to equal the sum. This exterior angle, 126 degrees, is going to equal these two angles added together. So when you write your equation, you would have 126 degrees equals 6x minus 1 plus 5x plus 17. And so when you combine your like terms, we would have this 6x and 5x, which is 11x, and negative 1 plus 17, which gives us 18. Okay, so then to get this to move away from the x, we're going to subtract 18, which gives us 11x equals 126 minus 18, which is 108. And then when we divide by 11, we get a decimal. Oh no, sad day. And it's 9.818, and it just kind of continues. So if I want to know the measure of angle H and the measure of angle J, if you have a graphing calculator, you can just have it continue these numbers for you. But we would want to plug in 6 times 9.818, and it just kind of continues that pattern, minus 1. And then we would also, not that. And then we would also plug it into the 5 times x plus 17. So that number times 6 minus 1 would give us 57.909. So we would just round to 91 degrees. And this would, let's see, 6 times that was angle H. And then for the other one, let me see if I can get it back to it. Nope. I messed it up somehow. And mine might be slightly rounded, but it is okay. Times 5 plus 17 would give us 66.090. So we would just round to 09, and that would be the measure of angle J. And when you add that to 57.91, that gives you about 126. Remember, we rounded, so mine is off a little bit. But if you don't round, it should equal 126 degrees when you add them together. So now for angle C, we have that these two angles are congruent, which means we can just do this thing times itself, or times 2. So that would be 11x plus 1 equals 2 times 6x minus 5, because there's two angles with that measure. So when we distribute, that would give us 12x minus 10. And then to solve this, we would want to get the x's together. So I would subtract 11x. I like to keep my x's positive, if you haven't been able to tell yet. And then I would want to add the 10 so I could get it away from the x, which gives me that x equals 11. So then if I want the measure of angle C, I'm going to plug into 6 times x minus 5, or 6 times 11 minus 5. That would give us 66 minus 5, which would then equal 61 degrees for the measure of angle C. So that is all I have for you. Your homework is on page 235. Oopsie. There we go. Your homework is on page 235. If you have any questions, just comment below. And don't forget to give the video a like if it was helpful, or if it answered any of your questions. And don't forget to subscribe to the channel so that you also get notifications when new videos are made. Hopefully this was helpful, and have a great rest of your day.